I'm Neil, and this is Chris, and we're both at Meta. And 4.5 years ago, we started working on the Buck2 build system, which we want to tell you about. So Buck2 is a build system. Think of it in the same space as Bazel. It's developed and used by Meta and has been in development for the last 4.5 years and is now our primary build system at Meta. It's a polyglot build system, so C++, Rust, Java, Go, Haskell, Erlang, OCaml, all your favorite programming languages. It's designed for monorepos. It's open source, so you can see the code on GitHub. And one thing we're very happy with is it's twice as fast as Buck1, which was its predecessor. So to go through the design of Buck2, which has definite similarities with Bazel, but definite differences as well. So starting on the right, which I appreciate very few of you towards the back can see, you have the targets files. These are written in Starlark, the exact same Starlark you know and love from Bazel, and they have the same kind of things. You call CXX library, and you pass the sources, headers, that kind of thing. These are specific to your project. Moving on, you have the rules in Starlark. One of the big differences here is in Buck2, all the rules are in Starlark. The core Buck2 binary has no language-specific knowledge at all. It doesn't know what C++ is. It doesn't know what Java is. And that means we have slightly richer APIs for expressing rules. So you can express things like depth sets, incremental actions, and other powerful features that you really need when you're writing very high-performance rules. And all the normal rules you kind of expect in a large system. And then coming over to the final slide on the left, the core of Buck2 is a Buck2 binary written in Rust. It provides the APIs which the rules use. It provides a Starlark interpreter, which is also available as a separate open source library. And we've spent a lot of time trying to improve the developer experience for Starlark, particularly our version of Starlark, with things like profiling, LSP, debugger support, linter, type checker. Statically typed Starlark is a thing, and we have it. It's great. We have a library for console output, again, separately open source library. And the core is also responsible for a lot of the performance work that we've done. So one of the reasons we started Buck2, as opposed to just continuing with Buck1, is we wanted to go faster, and about twice as fast. And that really does mean that our developers at Meta, who used to spend 10 minutes waiting for builds, now spend 5 minutes or even less than sometimes waiting for builds. So they really can get more done. And we kind of crunched the numbers, looked at our developer cohort, and found that engineers whose builds were sped up by Buck2 produce meaningfully more code. So you make developers' builds faster, and they write more code. They don't go to more meetings. They don't leave for work earlier. They actually do more of the useful stuff you're paying them for. So what kind of performance tricks do we have? So by having a high degree of abstraction, we can rewrite the core without rewriting the rules. As examples, the write file call, we've made that do about 100 different things, well, maybe 5 different things over the time. Does it write directly? Does it write directly to the cast? Does it buffer in memory? Does it buffer in memory compress? And because we have a high degree of abstraction in our rules, we can make those changes very readily. We have a single dependency graph. So analysis, build, all these things happen on the exact same dependency graph, which means there are no phases. There's no waiting for one thing and then going back to another. It just all happens on the same graph. And that's very nice both for a program maintainability, but also lets you get the best out of the build system. We have remote execution. Everyone wants that. And we pre-compute the Merkle trees as we're building things, and we use Blake 3. We have virtual files, so build without the bytes kind of thing. We've had that from the beginning. It's in Rust, so there's no GC. And we take care not to do anything that would harm the performance. So what's the good and the bad of Buck2 compared to, say, other build systems you may be more familiar with? So Buck2 is a powerful, fast, modern build system. It's actively developed, and we believe strongly in the open source. So if I land a change to Buck2, it will be in our GitHub repository 15 minutes later. We accept PRs. Send us a PR. We will merge it. If it's useful, we'll discuss it. And the Buck2 that we use internally is the same one that we ship externally. So there's no difference between the two, other than the RE version where for open source, we're compatible with the remote execution API of Bazel. The bad, changing a build system is hard. We're fairly new, so we only have a few external users, so expect some teething troubles. Some of the rules don't work open source yet, Java and iOS, but we're working on it. And we don't really have the whole BZL mod package manager integration story figured out yet. But again, we're working on it.
Great. And I'm just going to talk about some interesting features of Buck2. I'm actually going to clip over a bunch. Okay, BXL. So this BXL is just we encountered these problems with especially IDE integrations, but other like things that want to interact with the build system, where they need a lot of information out of the build system. They'll want to look at the target graph, pull out nodes, do builds, see outputs, etc. And this was, with Buck1, we saw a lot of this would be done in Python. Some of it was implemented in the Buck1 core itself in Java. And so with Buck2, we came up with this new idea, which was BXL. We call it the build extension language. And what is it? So BXL is that you write Starlark scripts. We provide an API basically to like everything in the build. So let's see, there's some examples here. Okay, you get command line arguments. There's like an example BXL command. You can look at the unconfigured graph or the configured graph, do queries on those graphs. Get out targets from your queries, say, and then run analysis for those targets. We have analysis very similar to Bazel analysis, and then pull out the providers. You can, in your BXL, you declare new artifacts, new actions, etc. And then it's integrated with dynamic features, which we didn't have time to talk about everything in these slides, but those are before this. So here's an example. I don't expect you to be able to like see this or anything. I hope we will be sharing the slides. I'm not sure. It is from Erlang. There's a ebin paths. I don't know. So what this is doing, it does a query over a graph, finds the Erlang tests and app targets, and then it just tries to build all of them, right? And so it's just Starlark code as, I don't know, normal. Here's some links to like examples of like real BXL code that we use. Erlang shell, which do you know what that is?
It's like a REPL for all your Erlang dependencies.
Great. So we have recursive check and clippy support for Rust is built via BXL. Our Rust analyzer integration is primarily BXL. And then Python source DB is another one. I believe that's also IDE support. 5 minutes. You want to just go to questions?
Yeah.
Yeah. Let's just go to questions. All
right, we have time for questions back there.
Hey, so I'm interested if you can talk a bit about the decision making of, instead of using Bazel, you decided to write a whole new build system. Yeah, how did that go?
So when me and Chris got given the project of make builds better, the options we considered were incrementally improve Buck1, write Buck2, and switch to Bazel. So we completely considered it. It has pros and cons. So we would have quite liked to switch to Blaze, but we were less keen necessarily on switching to Bazel. There were lots of internal details about the remote execution that we wanted to do a bit differently. One of the biggest problems is Meta has a huge code base. So we weren't really interested in switching to Bazel with the existing C++ rules, the existing Java rules, etc. We would have wanted to match the existing Buck1 rules behavior, and then perhaps as a future step, migrate to a more standard Bazel C++ rules. So that would have been a bit of a challenge, especially because things like the C++ and the Java rules are more baked into the core, and we weren't sure we would have the full power we needed to implement them outside the core. We also have requirements for things like support for OCaml, Erlang, Haskell. And if you look at things like the OCaml rules for Bazel, you have to specify every project, every node in every file in the dependency graph as a separate dependency node. Our OCaml developers would have come and killed us if we made them do that. So we were looking for a level of dynamic features that we have in Buck2 that don't currently exist in Bazel. But the migration was the large part of the story.
So you answered why you created Buck2, but why was Buck1 created?
Yeah, I mean, Buck1 was created before Bazel was open sourced. I'm pretty sure Buck itself was open sourced before Bazel was open sourced. And so, you know, it was certainly influenced by engineers' experience with Blaze. But yeah, that's the main thing.
One more question? Yeah.
So you mentioned the RE server difference between Buck2 and Bazel. Can you elaborate a little more?
I mean, I should almost give this to Andreas because he's written an excellent blog post about comparing Bazel and Buck. I don't know.
There's also, I gave a talk at the Iceland meetup. The recording will be available in 2 weeks or so, and the code and slides are online. Some of the things I focused on there is the difference between static and dynamic dependencies for some languages is really relevant, as was already mentioned before. So in that, I include a demo for Haskell, for example, and there are a bunch of other languages for which that is relevant. And then another difference is that I mentioned in that talk is that Buck2 relies on remote execution for isolation, whereas Bazel handles sort of local builds separately for isolation with a sandboxed mode. But as I understand, there is potential for fixing that on the Buck side as well. And then there is the dependency management point that Neil already mentioned in this talk. But then in the blog post, I also mentioned a few other things, like, for example, the Starlark extension API in Buck2 is typed, which is a very, very nice thing, at least I find. And it also is a bit more composable in terms of the primitives it offers. So, for example, if you look at the primitive to describe commands that you want to execute, it actually captures dependencies of the command you need to execute automatically for you. Whereas in Bazel, you have to track all those things separately and then forward it to run action in different parameters. Yeah, there are a bunch more things, like Bixel was mentioned in the talk. I don't know, there's probably a few more, but I think those were the big ones.
I would say we're probably more similar than we are different. Like, we were heavily inspired by a lot of things that went in Bazel, and for Buck1, things that were in Blaze before it. So if you squint, they do look very similar.
All right, then I think we're a good point in time for the next talk. But Neil and Chris are still going to be around, so come grab them for questions. And yeah, let's give them a hand once more.